Question 34. Which of the following equations has the greatest number of distinct roots for x between 0 and 360 degrees? Option A, sine x is equals to tangent x. We can change tangent x into sine x over cosine x here. And then we multiply cosine x on both sides. So cosine x sine x minus sine x is equals to 0. Sine x times cosine x minus 1 is equals to 0. Sine x equals 0 or cosine x equals 1. So when sine x is equals to 0, x can be 0 degrees, 180 degrees, or 360 degrees. When cosine x is equals to 1, x can be 0 or 360 degrees. So there are only 3 distinct roots for x because there are some repeated roots. Okay, and then for option B, sine squared x minus 4 sine x equals 0. Sine x times sine x minus 4 is equals 0. So what am I doing? Sine x equals 0 or sine x equals to 4. And we need to reject this one because the greatest value of sine x is just 1. So sine x cannot be equals to 4. So when sine x is equals to 0, x can be 0, 180 degrees, or 360 degrees, so 3 roots again. Option C, sine squared x minus 3 sine x cosine x plus 2 cosine squared x is equals to 0. Okay, we can make sine x into a and cosine x into b. So the equation becomes a squared minus 3ab plus 2b squared, which becomes a very nice quadratic equation. So a minus 2b times a minus b is equals to 0. So sine x minus 2 cosine x equals 0 or sine x minus cosine x equals 0. Okay, so sine x equals 2 cosine x or sine x equals cosine x. When sine x equals 2 cosine x, we then divide cosine x on both sides. And this becomes tangent x. So when tangent x is equals to 2, this is the graph of y equals tangent x from 0 to 360 degrees roughly. So when tangent x is equals to 2, you can see there are 2 solutions right here and here. So here I marked down 2 roots. And then for sine x equals cosine x, we then divide cosine x on both sides. this becomes tangent x equals 1. So again, we have another two different roots, so two more roots. So altogether, option C should have 4 roots. Okay, I can explain why I can make sure cosine x is not a 0 and I can divide it on both sides. It's because when cosine x is 0, then this right hand side of course becomes 0. And then when cosine x is 0, sine x can only be 1 or -1. So clearly cosine x equals 0 is not a solution. So I can make sure cosine x is not 0 and I can divide it on both sides. Part D, sine x equals 1 over sine x. We can multiply sine x on both sides. So sine squared x is equals to 1. Then sine x equals to 1 or -1. When sine x is equals to 1, x is only equals to 90 degrees within a range of 0 to 360. And when sine x is equals to -1, x is equals to 270. So there are two roots. So the equation that has the greatest number of distinct roots is C.